Hey everyone, Mr. Newman here, and today we're going to learn about, do some practice problems with domain and range, as well as some practice problems with comparing functions. So let's get started. First of all, use the graph below, use the graph right here on the right. You guys know what I mean. The function is continuous because you can draw it without picking up your pencil. You can also look at it and see how it's all connected. It's not separate points, separate dots. And so that's another reason it is continuous. That's going to affect the domain and range. So we look at this and go, all right, well, domain is the smallest x all the way up to the biggest x. The smallest x starts there at -1, and the biggest x goes all the way up to 2. Notice it's an open circle at 2. That means we're not going to include 2, but -1 has a closed circle. So we write it like this, from -1 to 2, we need to write -1 comma 2, and we put a bracket next to the 1, and we put a parentheses next to the 2, because the bracket means including -1, that's the filled in circle, and the parentheses means not including 2, that's the open circle. The other, that's interval notation. The other way to write that is using inequality notation, which looks like this. -1 is less than or equal to x, which is less than 2. Notice the inequalities are different just in the same way that the parentheses and brackets are different, because we're including -1 and we're not including 2. For the range, that's the y's. So we go from the lowest to the highest. The lowest is -2. Notice it's also an open circle. The 2 is there's not a point there like open or close, but we know that lines are a bunch of points, so there is actually a point there, even though it doesn't look like there is. So we go from -2 to 2, and we need to put a parentheses on -2 this time, because the open circle is there, and a bracket on 2, because we need to include 2. The function goes all the way up to that point. So not including -2, but including 2. The other way to write that is -2 is less than x, which is less than or equal to -2, or +2. And notice again how the inequalities match up with the not including -2, but including 2. For the second problem, we have these are the points. When we you don't have to use these points, but these are recommended points. Another comment is you can also use your calculator to find this table quickly. If you know how to do that, great. This is for those of us who don't know how to use the calculator, and or for those of us who don't have a calculator. When you're trying to find the output, if the input is -2, you plug this in here and you get -3. Notice I put a -2 everywhere there's an x. To plug in -1, we do the same thing, and you get a -4. Continue on like that. Here's our table. So I'm going to plot these points, and you notice what it looks like? It's a parabola. It's curved up. And if you fill out a few more points, you'll fill this out here. Now, the reason I drew it is because that helps me with the domain and range. The domain goes left forever and right forever. It's a parabola. And also notice, we should have had a good guess that it's a parabola, because looking at the equation, there's that x squared there, which helps us. So the domain goes from -infinity to +infinity, all reals. This is one way to write it. That's another way to write it. For the range, it does not go down forever, but it does go up forever. So we start at -4, and it's everything greater than or equal to -4. -4 is less than y, and yes, it does include that point, so we need the or equal to. -4 is less than or equal to y. Or you can write that like this, -4 including -4, but not including infinity, because we never include the infinities. For the next one, this relation shows how much rain has fallen over the course of several hours during a rainy day. First of all, notice 0, 0 is a point, so input, we first have to fill out this table here. The question asks us to do that right here. 0, 0 is a point. Plug in 2, the output's 1, 2, 1 is a point, 4, 2 is a point, 6, 3, and 8, 4, those are all points. So I'm going to fill out the table like that. This function is continuous for several reasons, and the more reasons you can explain on this problem, the better. One reason is because the graph is connected. It's a connected line and you could draw it without picking up your pencil. Another reason is that if you think of these amounts, the amount of rain in inches and time in hours, you can always have fractions of times between every 2 points. For example, you can talk about 1 hour or 0.5 hours or 0.1 hours or 1/10 of an hour, 1/100th of an hour, 1,000th of an hour. All those sections in between mean that that time just keeps continuing. And same with rain. You can talk about half an inch of rain or a quarter inch of rain or a 1/10 of inch of rain. So see all these points? All those points are reasons why we can have why this function is continuous. For the domain and range, we can look at the graph there. Because it is continuous, we need to write it with interval notation or inequality notation. I'm going to write down both of them here. Notice on the graph it starts at 0 because negative time doesn't make sense here, as 0 is when the rain started. And I'm going to write infinity. Now, no, the rain wouldn't continue on forever, but since we don't know when it ends, we need to say there are any number of possible times greater than 0 where this could end. So x is greater than or equal to 0, or from 0 to infinity, including 0. For the range, you actually have the same range, except you use y, because starting from 0 inches, we also have 1 inch, 2 inches, 0.5 inches. The reason you cannot just list what's in the table is because there are points that are included on the graph that are not included on the table. We need to consider those in this situation. All right, the other part, 2.6, is the other quiz you will take. Notice we need to find the rate of change. Rate of change is delta y over delta x. The most common error here is to flip that, so make sure you're putting delta y on top. The change in y here is adding 4. The change in x is adding 2. So we get 4 over 2. Now you cannot leave it like that because you can simplify this. That is 2. 4 divided by 2 is 2. For the next problem, use the graph. We have f of x, which is the curve, and you all know that's a parabola. And g of x is the line, the dashed line there. In order to calculate this, we need to know the input of -2 for f, that's the parabola. So we look at -2 and we find that the point is -2, 1, so the output is 1. For g of -1, that's right there on the x-axis, so we know the output is 0. 1 is greater than 0, so I'm going to fill in that inequality there. 1 is greater than 0, so f of -2 is greater than g of -1. The maximum of this point, of this function, of f of x, you know that's the topmost point. So I'm coded in red there. And so the input is -1, the output is 2. So the way I fill out those blanks, f of -1 equals 2. That's the maximum of f of x. For the last problem here, this is the big one. Mr. Newman asks his 2 sons to rake leaves, Benji and Daniel. Daniel picks up 5 leaves every trip and puts them into the pile. Benji's clever and realizes he can double up, so each time he picks up according to this table here. And I didn't label the table Benji, but it was labeled in the explanation, so you can write Benji up there up top. The first thing I would do is I would write these both in the same format. Since the right side is a table, and tables are nice, let's make a table for Daniel. So Daniel picks up 5 leaves. Every time he walks out to go get some more leaves, he picks up 5 of them and brings them back to the leaf pile. So we have trips and leaves. After no trips, he has no leaves, but after 1 trip, he has 5 leaves. After taking 2 trips out, he gets 5 more leaves, that's 10 leaves. After 3 trips, he has a total of 15 leaves. And you notice the rate of change is constant, so it's a linear function. For Benji's, however, his is not constant. It is multiplying by a constant ratio, so therefore it is exponential. The domain of the function for Benji's leaves are right here. Now notice this is discrete because he can't take half a trip. He's either taken the trip or he hasn't to go get more leaves. So this is the domain, all the whole numbers, 0, 1, 2, 3, 4. And what does it represent? Well, it represents the number of possible trips he could take. This is how many trips Benji could take. The word could is very important. It's not how many trips he did take. He could take 1 trip, he could have taken 2 trips, he could have taken 3. Those are all the possible number of trips. He couldn't have taken 1.5 trips. He also could not have taken -2 trips. So the domain are all the possible trips, or the possible number of trips. The range for Daniel is going to be this right here, the number of leaves, because range is the output, the y value. So here we have 0, 5, 10, and 15, and so on. Those are multiples of 5. So you could write it either way, the 0, 5, 10, 15, ... or multiples of 5s. What does this represent? Well, this represents how many leaves Daniel could have in his pile. He could have 5 leaves. He could have 10 leaves. He can't have 8 leaves because he grabs 5 leaves every time. And he can't have -5 leaves because it starts at 0. Who will pick up more leaves after 3 trips? Well, let's just circle that on the leaf pile. Daniel picks up 15 leaves after 3 trips, and Benji picks up 8 leaves. So Daniel has more. Notice how it says justify your answer? That right there is the reason you have to say how many leaves each boy has. If you don't say that, you have not justified your answer and you haven't answered the question. Who will pick up more leaves after a total of 6 trips? Well, Daniel, let's make a little more of the table here. After 6 trips, it looks like Daniel will have made 30 leaves. You could also figure that out. 6 times 5 is 30. So he's got 30 leaves. And Benji, on the other hand, we just need to fill out the rest of the table. Notice it's times 2 every time. So 32 times 2 gives you 64. Benji would have 64 leaves. So Benji has more this time. Once again, justify your answer is the reason that we have to write out the numbers. Now for the last problem, it says Benji and Daniel do this for 5 minutes. If each of them can make 3 trips in half a minute, who picks up more leaves at the end of 5 minutes? What's this whole, if each of them can make 3 trips in half a minute? Well, what I would recommend for this kind of problem is I would recommend drawing a picture. Not of leaves and piles, but I'm going to make a picture here on the left of all the minutes. So we have the first minute, the second minute, the third minute. We're just going to diagram how many leaves are picked up. So if each of them can make 3 trips in half a minute, that means every half minute they make 3 trips. Like that right there. See, this is the first minute. In half a minute they make 3 trips, so I cut that minute in half and I put a 3 for how many trips they made. Then every half minute they make 3 more trips. Notice I'm breaking the 1 and the 2 into half minutes and break all of them in half minutes. That way I can count how many there are. Well, we really just need to do 5 times 2 to see how many 3s I have there. And that should be 10 3s. 3 times 10 is 30. So that's a total of 30 trips. Well, that helps me figure out how many trips there are. How do I figure out how many leaves they each have? Well, I don't really need to do that here because I noticed Benji is picking up way more leaves the more the situation goes on. Notice right here at 3 trips, Daniel has more leaves, but at 6 trips, Benji has more leaves, and Benji's getting way more leaves at a faster rate than Daniel is. So you can simply answer that Benji has more leaves after 30 trips because exponential functions grow bigger faster. You can keep multiplying by 2 if you want to find an exact number. That would be another good way to justify your answer, but you don't have to, as long as you make the observation that exponential functions grow bigger faster. Thank you very much for watching.